Hi, I'm Matt Hendricks. Welcome back to the channel. In my last video, I talked about how we select peer institutions for our benchmarking studies that we do in higher ed. This video is going to completely switch gears and throw that out, essentially showing you a way to benchmark without having a peer set at all. Instead of using a peer set, we're going to have an AI predict outcomes. And then we'll compare actuals, the university actuals, to the predicted outcomes. So it's a completely different approach to benchmarking. And so let me get into the outline of the video. I'm going to dive into a little bit of the detail of the model, how this works. So basically, it's the same sort of AI architecture that underlies the GPT-4 that you're all hopefully have heard of at this point. It's a neural network model, although it doesn't use like attention layers and things like that. It has a similar sort of architecture. So I'll talk about the architecture and why this approach might be something you would think about employing at your own school. And a tool that I've already made, so I'll show you all that. So here's the outline. So last time I talked about sort of what I call traditional benchmarking, where you select a peer set and compare your institution to the peer set on any metric that you're interested in. So there's several reasons why that's sort of the traditional, most popular approach, I suppose. One is that it's really transparent and easy to do, right? Two reasons, really. It's really transparent what you're doing. You're just selecting a peer set, although sometimes peer sets are selected in a sort of ad hoc way. And last time, and again, my video last time was showing how you could do it more scientifically. So it's transparent. You're just basically comparing means in the peer set to your current institution's values. Really easy to do that. It doesn't require any like sophisticated coding, really. Of course, we do our traditional benchmarkings here at Prospective Data Science. A little bit more sophisticated approach. We do select peer set. We use a machine learning algorithm to select the peer set. And then we don't just simply compare means. We look at conditional means in the peer set. So even the peer set, there's going to be a lot of variation in the size of the school, for example, size of the schools in the peer set. So what we try to do is, inside the peer set, what's the predicted value for the target school given its size? Usually that's the kind of conditional mean estimation that we do inside of the traditional benchmarking. So one of the weaknesses, though, that you'll encounter with traditional benchmarking is that there's always going to be disagreement on the peer set. And a lot of that can be mitigated if you just pick a bigger peer set. If you have one or two peers that are maybe don't fit, it shouldn't matter a whole lot if you have, say, 35 peers like I recommended before. But if you have like 5 or 6 peers and 2 of them are controversial, that's going to be a problem with getting people to buy into the benchmarking results. And in fact, the benchmarking results probably won't be accurate if you're using a peer set that's small and maybe controversial. Another thing is that in traditional benchmarking, one of the issues you're going to face is if you're looking at, say, tuition revenue or recruiting outcomes, that might be a different peer set that you use for that compared to if you're looking at sort of spending allocations. The peer set should vary with the outcome that you're looking at to some degree, depending on whether you're going to include competitors or just similar peers that have similar financial structures. The peer set might change. And sort of compounds the issue with having a peer set that people just don't want to agree on, right? It's really hard to get buy-in, especially in a university setting where buy-in is so crucial to get things done. And of course, the small sample issues, imperfect peers, outliers is always going to plague a traditional benchmarking approach. So I'm proposing a new approach. I don't know if it's new. I haven't seen anybody do it before, but I'm doing it now and I love it. It's basically an approach where you throw out this idea of picking a peer set, and it has many advantages and a couple of weaknesses that I'll point out that I think can be overcome as people get more and more used to using AI kind of models. So the strength, of course, is basically fixing a lot of the weaknesses of the traditional approach. The AI approach that I'm proposing basically takes a whole bunch of characteristics of your university and looks at all universities in the world or in your data set, in your population, and learns basically what, say if you're, one of the example outcomes I'm going to show you is what total spending should be or what instructional spending should be. So that you're going to train an AI to learn what a normal spending pattern looks like for a school given your characteristics, right? And the way it's going to learn that is with a neural network model, similar to how the AI models that you're used to using today operate. They learn language patterns. This one's going to learn spending patterns, for example, or if you apply it to like recruiting or retention, it's going to learn those characteristics, learn those patterns and how they're related to the characteristics of the schools. And in that sense, it'll learn what is normal for a school of your characteristic set. And then you're going to compare your actual values, your actual spending to what the AI is saying is normal for your school. That's basically the idea behind this different approach I'm proposing. So it's going to predict outcomes really flexibly. And it's not going to rely on a peer set at all, other than the fact that it's going to learn how your spending, for example, varies with your revenue, varies with whether you have a hospital, varies with your tuition revenue, the size of your student body. It's going to learn all of those relationships and then make predictions for every school really flexibly and without the need for a peer set. And so, again, one of the advantages is that you're not going to have the controversy with the peer set. It's also going to be a lot more robust. It's going to learn these relationships, which can be pretty complicated, right? It's going to learn these relationships really flexibly and just fit any kind of school that you can throw at it. Even schools that don't exist, it will be able to predict what the spending or what the retention rate should be, what a normal value would be for that type of school. So in that sense, it's going to be a lot more robust, but it has one big weakness, and it's tough to overcome this, although I think it will happen over time. One of the biggest weaknesses, of course, with this approach that I'm proposing is that it's not very transparent how the AI is making its predictions, right? It's going to be a neural network approach that is very complicated. Even if I showed you all of the weights that it decides that its training learns, it's going to be really difficult to figure out exactly how it is making the predictions it does. You can do it with some effort, but it's not as clear cut, of course, as just comparing the means to a peer set. Comparing your values to a mean in a peer set. So it's not... Sorry, I lost the screen there. It's not as transparent, which maybe if you're outside of higher ed, it's not a huge deal, right? If you're like managing a for-profit institution or something like that, it's okay. If the management understands how it works, it's maybe okay to just be a top-down. But in higher ed, it's going to be very complicated where decisions are made based on lots of different groups, input. And if nobody really understands how this AI works, it might not be very influential in the end in helping shape decisions. So it's one of the big problems with this approach. But I'm hopeful that over time, people will get used to these neural networks, understand that they're somewhat a black box, although they're very sophisticated black box, and they make predictions similar to what a human being would after learning lots of different examples over time. So it's like having a really wise person on your administration or board making sort of recommendations for you. Okay, so a little bit about how this works. I already have one of these working. I have an app called AI Trustee. So why did I call it that? Well, I think one of the most important things that trustees can do at a university is oversee how the money is spent, right? There's a couple of things that you need to watch. One is you got to make sure that the institution is financially sustainable, so you're not spending above your means. Really simple, right? Another thing that the board of trustees needs to ensure is that the money is being used efficiently, right? You want to make sure, so basically they should be optimizing sort of classic econ problem. How do you sort of instead of maximizing profit like a normal business would, given your budget constraint. I think the university's objective is to maximize their delivery on their mission given their resource constraints, right? So there's a couple things to that. One is you got to stay within your resource constraints, right? You don't want to spend above your revenues. Another thing is you want to allocate the money in a way that maximizes your sort of delivery on your mission, or the quality of the delivery on your mission. And that is going to involve, ensuring enough money is getting into, hiring faculty, retaining faculty, having great staff, lots of decisions go into that. So one way that you can sort of identify as a trustee whether your institution might have an issue with how it's allocating its resources is just to look at how other similar universities are allocating their money. And if you're very different, then start asking questions, right? Like, why is our competitor or peer over here spending so much more on research or instruction than we are? Is that going to be a problem? Why are we doing that? Why are we spending more on administrative functions than those other institutions, right? These are big questions that trustees should be asking, and of course getting answers to, right? But you can't ask the questions unless you know that there is a difference. And so that's where AI Trustee comes in. AI Trustee is going to point out these differences using this AI approach that I already mentioned. So this is all about spending. AI Trustee, what it's going to do is compare an institution's current spending versus their revenue versus what the AI would predict would be their spending. All right. And the AI is going to predict using that neural network approach that I'm going to outline in more detail in a minute. Let me give you a couple examples that I've written about in the past. I'll start with one school that merged, basically is merged with Mills College, merged with Northeastern University. And this is a neural network that's a fairly, computationally intensive application. This is running on a GPU to give it speed. So there's a few things I want to draw your attention to. This first graph here for Mills College shows their operating revenues in black, operating revenues coming from their audited financial statements. And that's another video, right, where I talked about how we're scraping data off of audited financial statements. This is that data, right? You can't get this off of iPads. So operating income, comparing that to their actual expenses, how much they're spending, all right? And of course, the gap would be their net income margin, but it'd be negative in the case of Mills, except for 1 year. But ideally, it would be positive, right? And that's what the AI says. The blue line is their actual expenses. The green line is what the AI model predicted should be their spending for each of these years. Notice how the AI says that, to be normal, you should be spending less than your revenue. And that's something that, of course, has to happen sort of by rule. Otherwise, the school goes out of business, right? Basically what happened with this one. So what you can do with this model is compare your actual spending to your predicted spending. And you can see that Mills is always really high on their actual spending compared to predicted, except for 1 year. And of course, that is not sustainable, and that's why the school is no longer around. But that's one of the things that this model can be useful to see, is this gap in how it's persisting over time. Or maybe it wasn't an issue a few years ago. In case of Mills, it goes way back before 2015. Another panel I have here is looking at specific spending categories over time. So this is just overall spending. This panel is looking at instructional spending or academic support or any of the functional categories that you want to look at. And so again, it's showing actual spending versus AI predicted spending. And this is one of the issues that I was trying to point out with Mills, is that while the school is having financial problems, they're allocating a lot more money to things that are not as mission critical. Typically like administrative type tasks that are in academic support and institutional support. So you see their spending sort of explodes here on academic support, while their predicted spending should have decreased, right? The AI says, hey, we should be spending less on this thing, and they're spending a lot more. And I believe the same thing happened with institutional support. Yeah, you see in 2021, they should have been spending about $12.9 million, AI predicted. Their actual spending was, 12.9 million. Actual spending was 14 million. And then you can see instruction, actually pretty close on instruction, very close at the end here. This is only going up to 2021 because Mills merged with Northeastern University, so their 2022 data, I think, is merged in with Northeastern. Okay, so that's this panel. And then finally, the bottom bar panel is showing relative allocation outcomes in a more, like, looking at one time period, the current time period, the most recent time period, and comparing total expenses to predicted expenses, and doing the same for all of the functional categories. So again, one of the issues that I was trying to point out when I was working with Mills is that, a lot of what they flagged as like some of their spending problem was in the instructional category. But you can see the AI says, hey, like the instructional spending at Mills looked pretty good, right? Their actual spending, the black bar, is actually really close to their predicted spending on instruction. It's the other categories that were the problem, right? They have a lot of spending they're spending a ton on academic support, spending a lot on auxiliary enterprises, and this turned out to be partly due to a really expensive food service contract that I highlighted in a previous video showing how we used 990s to identify any potential inefficiencies with contractor spend. Again, institutional support, this is upper admin, higher than expected. Public service, higher than expected. That may be normal, though. I think this might have been a museum that they have. Student service is actually below expected. So the solution here, obviously, if you're looking at this, is think about, okay, how can we pull this back down, or what's making this spending higher than normal? Pull this down to expectation, pull this down to expectation, and ultimately get your total spending back down to the sustainable level predicted by the AI. That's how you can use this tool. And it's important to keep in mind here that this is an AI model that's taking into account lots of things. It's taking into account and I'll show you these variables in a second. It's taking into account like dozens of variables, including the fact that it's a small school, including the fact that it's in California. Lots of things are accounted for in this neural network approach. All right. So one other thing that this model allows you to do is, instead of looking at the current time period, so it's looking at 2021 in this case, you can make predictions, based on what you project your revenue to be in the future, right? If we expect our revenue to fall to 42 million, then your custom predicted spending should be these green bars, right? You're going to have to cut spending in a lot of areas, right? Or if you're expecting to get a bunch of revenue coming in the future, you're going to spend a lot more, right? If you expect your revenue to be 108 million, you probably should target your overall spending at 103 million and allocate this much money to each functional category. That's what the AI is saying. That would be normal spending for that amount of revenue and your other characteristics. So that's how you use this model. Let me show you another school that I've written about. Interesting case of St. Xavier. Again, this is available for any school, really. Every school in the population is in here unless they have a ton of missing data, and I threw those out. So you got private four-year colleges, and you also have only 4 years, by the way. Also have public four-year college universities and colleges here. I'm just focusing on private right now because I want to show you another one that I've written about, St. Xavier. I think it's just really nice to have this view, too, to put things in perspective. So St. Xavier did have a financial issue for several years back in the early 2010s, like 2016, 2015. This is their actual spending again, the blue line, compared to their predicted spending, which is the green line. So they had a budget deficit, that's the gap here. Their predicted spending was quite a bit lower than their actual spending. Well, they fixed it, but one of the things that I wrote about is that they overcompensated here and made cuts that were far deeper than was necessary. In fact, far deeper than what would be recommended by the AI, right? And by me. All right. So, for example, in 2022, the most recent data we have here from iPads, their actual spending was, I'll highlight this so I can get it. Actual spending was 67 million. Predicted spending is 74 million. So they're spending quite a bit less than what the AI would expect they would spend given their revenue, because their revenue is 76 million. This is operating revenue right off the audit. There's a long story as to why this is going on, and way more than I have in the video. But one of the lessons from this case is to make sure, if you're an administrator or board member, to make sure your operating budget matches reality. All right. The operating budget is supposed to predict the future, right, and be accurate. And St. Xavier, I think, I don't know this for sure, but I've heard a lot about this. I think they had an issue where their operating budget was not matching reality. There's a lot of things that should have been in the operating budget, revenue sources that were not being included. So they had this sort of disconnect in that they felt like they had a financial crisis, but they actually didn't if they accounted for all of the operating revenue that they were going to get every year. So the budget was showing a very different story than their actual audited financial statements, and that's a big problem. And so make sure your budget aligns with the true actuals, right? The ones that are on the audited financial statement. All right. So again, how they could have used this. Again, St. Xavier has a similar story, although they're underspending, right? They should have been, let me clear this. They should have been spending, their institutional support spending looks fine. Again, one of the issues that I found here and that the AI is suggesting is that their spending on instruction is low, right? They should have been spending quite a bit more, but they were doing the opposite, right? They kept cutting instruction and they cut other things too, but cutting instruction, the thing that's probably most closely linked to their mission and unnecessarily, in my opinion, and they have the sort of opposite issue, student service spending is higher than normal. And again, this accounts for, I always get a lot of pushback, like this accounts for, well, this school has a lot of low income students. Yeah, that's in the neural network model, is accounting for that and predicting what your spending should be given your student characteristics as well. And I'll show you that in a second. All right. Okay, so that's how you can use this AI. This is free, by the way. Everybody can use this, and I suggest you do. It gives you a really good start as to figuring out, whether your spending allocations are good overall, or if your relative spending allocations need to be tweaked, or at least looked at in more detail. This is the place to start. All right, totally free. aitrustee.highered.ai. Of course, I give this to you for free, because there's a lot of work to do after you see these gaps, right? There's a lot of work to figure out, why is academic support not aligning with what the AI is predicting and so on. Same with instruction. There's a lot of digging to do after you realize these potential issues are existing. Okay. All right, so that's my new approach, and I hope it catches on. It's really powerful. I use it in concert with traditional benchmarking in all of my work right now, and it almost always shows the same thing as traditional benchmarking, but it's nice to have two, right? Two models showing the same result, be it, instructional spending is too low, or, you're spending too much overall, or something like that. It's nice to have alignment, but I generally like the neural network model approach better because it's far more robust to nuances in the structure of a college. All right, so let me go into some of the details about how this AI model works, and I'll wrap up this video. So let me show you a bit of the code. I'll give you some details about the structure. It's basically two neural networks. All right, one neural network predicts total spending, given a bunch of characteristics of the university, college. Another neural network predicts relative spending, right? So what percentage of your total spend should be going to different categories. And again, it predicts that based on a whole series of characteristics of the university or college. I'll show you the variables that are included and then a little bit about the architecture for these two models. Before I lose you in the details, I'll just tell you that, again, we have two neural network models. They're both what we call an ensemble type approach, where I actually estimate 100 of these for each, right? So really it's 200 neural networks, right? 100 for the total spend side, 100 for the relative spend side. And the ultimate prediction is the average of all of the predictions of those 100 neural networks for each outcome. Hope that makes sense. Why do I train 100 of each? It's simple. We have small sample size that we're looking at relative to what, trillions that you have for like a big AI model. And the results are pretty sensitive to which schools end up in the training or test set. So to overcome that, I randomly generate these training and test sets 100 times and then train neural networks on each of those samples and then average the output of all of those randomly sampled and train neural networks, if that makes sense. So each neural network has the same architecture within the random sampling, and they're all early stopped. So that's really key. So we have a training and test set for each neural network, and I train it until it stops improving its predictability, or it's improving its predictions on the test set for that particular sample. So there's a lot going on there. I'll show you a little bit, but I think maybe the most important thing for you to understand is what variables are going into these AI models and how it so flexibly fits the model. Basically, it gets its strength from having a lot of trainable weights, all right? It can be very flexible in how it makes predictions. It can predict on all sorts of things, including having different marginal effects for the same variable, different interactions of variables, whether you're a poor school, or not a poor school, but a school with relatively poor students in that has, low net tuition revenue or something like that. It will understand that and how that's related to spending allocations. Maybe those kinds of schools spend more on student services, for example. It learns that from the data. All right, relatively more, right? Maybe not more overall, but just relative allocations might be different. All right, so there are two neural networks. All right, one has 7 layers. The neural network that trains for relative spending allocations, that has 7 layers with 27,000 trainable weights. So it's really flexible kind of way it can fit the data. The neural network predicting total spending doesn't need to be as complex. In fact, that's what I've learned from trying this hundreds of times, right? I've tried all sorts of different iterations with different layers, different trainable weights, different nodes. And the best architectures I've found are 7 and 3. So a little bit less complicated, quite a bit less complicated neural network for predicting total spending. Because really it just depends on how much your revenue is, right? Whatever your revenue is, pull your spending down a little bit below that is basically what the neural network, the AI learned. All right, that's ideal. And that's what's normal for most schools. Of course, you have some that spend beyond their means, but that's not the norm. So that model has 5,631 trainable weights. And again, the predictions are produced by averaging all of the predictions from each neural network. There are 100 for each of the outcomes, so it does a lot of calculations in the background. All right, let me show you a little bit of the code here. So this is the actual code that runs the relative spending neural networks. And then I have the one that does the total spending for private schools. And then there's another one that does it for public schools too. So there's really 4 scripts here. I use PyTorch and PyTorch Lightning to train the neural networks. Let me show you what the data looks like. So this is the relative spending. I'll show you the X. Those are the inputs into the model. Take a second. All right, so here's what's going into the model. Have a control so the model can learn that maybe the year influences relative spending, right? We had COVID recently, so that influenced relative spending in 2021 and probably 22 as well. Maybe, some people were maybe not spending as much on auxiliary enterprise since you closed the dorms and things like that. All right, I have a variable for whether the school has a hospital, whether it has a medical school, whether it's a historically Black college and university, the Carnegie classification, the number of first-time freshmen, number of transfers, All of these are normalized, by the way. As you might look at the numbers here and be like, those are weird fractions. They're all normalized, standardized. So to have a value, sort of a mean of 0 and a standard deviation of 1. Full-time undergrads, full-time grads, so just get a sense of the student makeup, the kinds of revenues that the school has, their tuition and fees, their educational sales and sales revenue, auxiliary revenue, if they have big time athletics, or if they're a residential campus, it'll typically be higher. Their hospital revenue. Some schools have huge hospitals, so that influences how they allocate funds, of course. So we have their hospital revenue, independent operations revenues. These can be like museums, I believe, and other independent. If you have a school, like a K through 12 school or a daycare center or something like that, could be revenue coming in there. Whether they get a lot of private grants, federal grants, big research institutions will get a lot of these. How big their room capacity is. They have a lot of dorms or not. Are they residential kind of campus? Do they have big time football? Do they have football? Are they in a Power 5 conference? Do they get a lot of applications? So this is where I get the undergrad income levels. Do they have a lot of Pell Grants? What's the retention rate like? Really wealthy schools or really selective schools tend to have retention rates that are outstanding. So that will pick up a lot of that. How selective the school is, percentage admitted, their yield rate. These reveal a lot about the type of school. This is the net price for a student that has $110,000 family income. And so that reveals a lot about the school as well. Some of the elite schools charge these students a lot of money to attend, while others not so much. And it reveals a lot about their operations, prestige, and things like that, and then total operating revenue. So basically, these are the variables that go into the model predicting relative spending, right? It's going to learn all these relationships, interactions of these, right? It will learn that big schools that have Power 5 schools that have a lot of room capacity, have football teams, will probably spend a lot on auxiliary enterprise because they have this big football program, right? It will learn that over time when I train it, or when I did train it. All right, and make accurate predictions based on those characteristics. All right, so I have a similar approach for predicting total spend. Really the same inputs going into that model. And it's just predicting a different outcome. The outcome in this case, the Y vector is relative spending, so the percentage of spending that goes to different functional categories, whereas in this model, the Y is total spending overall. All right, so the rest of this is just the architecture. I'll show you a little bit about the architecture of the model. Here is the architecture for the neural network. So I have 1, 2, 3, 4, 5, 6, 7 layers, as I mentioned. And each of these has nodes defined by out, I guess, this column, 110 nodes, 30, 70, 30, 70, and then out to the number of classes in this case. Yes, number of classes, so it's each functional expense gets a different proportion of spending at the end. Maybe more than you need to know, but basically here you can figure out the number of trainable parameters. It's actually here. And I told you it's about 27,000 trainable parameters for one neural network. And then there's a loop that happens here at the top. So I'm going to train 100 of these neural networks with early stopping so that they stop as soon as they stop, improving the accuracy of predicting outcomes on the data that it hasn't seen for that training, all right, for that neural network. So that's a way to avoid overfitting. And I train 100 of these and put them all together and make predictions, average all of the predictions from from all 100 of the neural networks. All right, so that's how these AI trustee values are generated, right? So the AI predicts what their what the spending should be, this green series here. So AI predicted, and we compare that to actuals, and that's this new way of doing benchmarking that does not involve, doesn't involve peer sets, but it does have the drawback that it's a lot more of a black box as to how it works. All right, I hope you enjoyed this, and you might think about doing something similar at your school. Like I said, in my practice, I have found that it's quite useful to do the traditional approach still, since it has all the transparency and all of that, and then just cross-check that against the neural network model. They almost always agree. You know, if there's underspend, overspend, spending too much on instruction, too little on instruction, it almost always agrees. But it's nice to have the robustness check with a far more robust model in the AI Trustee neural network approach. So use it. I urge you to use it. It's totally free. I don't even ask for any email, nothing. All right, the link to AI Trustee is here, and I'll post this outline in the comments on the video. All right, hope you enjoyed. I'll see you next time.